Hello. Hey,
Hi.
everyone. So yeah, for a quick introduction, what we do with this Stakpak. Welcome to the sixth Stakpak Ship It. Is this the sixth or the fifth?
The six.
Sixth. Okay. So welcome to the sixth Stakpak Ship It. What we do is we take like a Stakpak's open source DevOps agent and we do real life tasks with the agents. And we do very little preparation. So the amount of preparation we do is just build the project we're going to do the task on, but we try things with you raw and live. So you can see like what the agents can do and what they can do and how to use them to do stuff like real kind of infrastructure work in your infrastructure. So first, give me a moment to set up the lab here. Okay, so you ship it for 6. Okay, so in this setup, we're going to try, 6 Stakpak Ship It already. Yeah, so in this setup, what we're going to do is we're going to do cost estimation and use the agent to explore our setup, like a Kubernetes cluster setup. Enumerate the resources, check out the costs, and suggest ways we can cut these costs. So I've been setting up the lab or the cluster. We're going to use the ship it infrastructure from like the ship it infrastructure we did on the fourth ship it or ship it number 4. We're just going to deploy that and then run the cost analysis on this sandbox AWS account. So just I need another moment to finish setting this up and sharing my screen. So let me hear. Yeah, please tell me if my screen sharing is not working. So
George is recorded, right?
sorry, what?
Is the session getting recorded?
Yes, it should be, right? No?
Yeah, I just wanted to make sure.
Okay, so I'm showing, just double checking. How do I make sure it's recording? I don't know. I think it is. Like since you started streaming, it's already is recording. I can't find a setting here. I don't know. I mean, if you're streaming, it's already recording on YouTube. It's not doing a local recording though. Here. Yeah, we're already live. I mean, if you want to allow like enable local recording, you'd have to end the stream and then switch the setting and then stream back. But now since we're live, it's just like being recorded on YouTube and LinkedIn. But it's not using a local recording setting. But I mean, that's fine. Like we should proceed anyway.
Yeah, it's okay.
Yeah, okay. Okay, so I'm going to share my window and let me know if it's ready, Noor. So here, so yes. Yeah, okay. So
Now
if
we can
it's
see on screen.
laggy for any reason,
No, it's working good.
Okay, amazing. So yeah, I would need to, I'm switching between another screen because I'm fixing something last minute with the setup, but I think it's working. Okay. Okay, so we can spin up Stakpak. So we just launched an official rulebook to make cost estimates much easier. But yeah, you could already do it without this rulebook. So how the rulebooks work is like when you go to Stakpak, you'd find that there are rulebooks available for you. Some of them are official. Some rulebooks we are fine-tuning for you in our team. So we're doing a lot of testing to make these rulebooks higher quality to do different things like Dockerizing an app, or like in this case, calculating cost estimates for a cloud account. So we optimize this rulebook to use here. But you can also fork these rulebooks and add your own knowledge to it. So you can customize the rulebook for your own environment with your own best practices. So here, let's start with this setup. So this setup is a Kubernetes cluster, the one we deployed on the 4th Stakpak Ship It, and we're just going to analyze it. So analyze my AWS account costs and suggest ways we can optimize them. Yeah. So here, Stakpak decided to read the cost estimation rulebook, which gives it a structured way to be able to do this. So it's checking the current date. And it's going to see fetch historic data from the past couple of months in this account to build a model of how the costs are changing using the Cost Explorer. I think we're using the wrong account. So you have a couple of sandbox accounts. I think I didn't choose the right profile. So here I switched to the profile where I deployed the EKS cluster. And yeah, we can do the same thing. So analyze my AWS account costs and suggest ways we can optimize them. So I decided to fetch reports from May, June, and July because these are the past 3 complete months first. And yeah. So this is a sandbox account. There's no patterns yet because we keep deploying and deleting stuff on these accounts for demos. But now what it's doing is after it got the historical data, it's actually listing all my existing resources because it found a lot of abnormalities and spikes in my history. So it checks the historical data using the AWS Cost Explorer through the terminal, but it's also enumerating all the services we have live now to see the current costs we're currently spending, the stuff we're currently spending. And yeah, we can actually check these out now as it's going. So here in May, these are the costs for May for different services, $22. And for June, $23, but for July, it's $130. There are some spike and some new stuff like EKS cluster and Route 53 and so on. But then it's doing enumeration to get our current costs. So here, you figure out that EC2 is increased, EC2 also compute is increased. So this is EC2 other, the volumes, data transfer, and so on. But here's the compute and the EKS cluster and RDS. So these are increases. And yeah, it keeps enumerating the resources. So it's checking out everything we have in the AWS account to account that in the current cost structure we're having. Yeah, so I can see the messages. So please, if you have any messages, just ask Noor to read them out loud while we're doing that. Yeah. Okay, it found out my costs hiked or spiked in July because of these specific changes. And we have 30 unattached EBS volumes that we don't use anymore, which is wasting from $45 to $60 per month. Yeah, it's costing us $60 per month. NAG gateway, I think these are all stuff we forgot about while building all these experiments. These are just stuff that we forgot about. And we have 3 NAG gateways that we're not using anymore. Only we need 1 or 2 for high availability, not 3. So it's suggesting we delete one of these extra NAG gateways. Okay, so let's keep going. So yeah, it started coming up with optimization recommendations. One of them is deleting the 30 unattached EBS volumes that we don't use anymore, which are costing us $150 a month, and then consolidate the NAG gateways from 3 to 1, which would cost us $90 a month. And also review the EKS necessity. So 37 per month if not needed, because we have an EKS cluster. So if we don't need the cluster, just shut it down. So that's the most effective way to start saving costs, is actually killing all the unused, underutilized resources. But then like these are immediate action. These are like quick wins that would save us $200 a month. But like there are medium time optimizations like right sizing the instance if we have, if it's underutilized, or implementing an EBS snapshot lifecycle policy. So we don't have to store all the extra data or set up cost and alerts and budget. So these are a lot of things. Like we're going to test that now, go through them now. So priority 1, and it gives us example on how to do this. Priority 2, consolidating the NAGOD ways. It also asks us here to maybe we try backup the volume before deleting it by creating a snapshot, so we don't lose data. But it's cheaper to keep the snapshot compared to actual volume, I think. Yeah, consolidating the stuff and so on. So okay, so here it lists some stuff, priorities. We can also like check the EKS cluster, because this is what most likely. So most of the costs you need to cut are usually compute. So I can ask it to make sure my EKS cluster is right sized, for example. So it's using Fargate. It's super efficient. I don't think there's a lot to do there, but like, yeah, I want to show you how we do this. Yeah. So we're paying $73 per month for the EKS control plane, which we have to run anyway. Because we're paying per pod, we're using Fargate, so it's serverless. No managed node groups. So Fargate is more expensive than managed node groups or EC2 machines. So this is one kind of cost optimization we can make. Instead of using Fargate, we can use node groups. I mean, this would work great if you have workloads that run all the time. So you need to have these things up all the time. Yeah, so this is actually something good. So how much we could save if we switch using EC2 node group instead of Fargate, for example. It's doing more research on the different Fargate profiles we have. Checking the stuff running on the cluster. So it created like a manifesto of sort of everything running. So we have 3 Fargate profiles: default kube system and ingress Nginx, and we have 5 running workloads, Nginx pods. 3 of them are Nginx public, and 2 of them are like replicas from like an Nginx test workload deployed. So now it's looking up the official AWS documentation to get the actual pricing for Fargate and EKS, so you can compare it to EC2.
Mustafa has a question. He's asking if we can trust it enough to do that and not break anything. Like, can Stakpak do the switching itself?
Yes, so I would split this into parts. So the first part is the analysis part, we should do in read mode, and you can do this using Warden, like how we did it like the last Ship It session. Using Warden would make sure that it doesn't have the agent cannot break your AWS setup. And then you get a report out of that. And then you review the report for the cost savings, and then ask Stakpak to make specific changes one at a time. Here, like deploying the setup, I used Terraform, and that's what I'm going to use in the future when I'm making changes. So instead of making changes directly, some migrations between workloads would require intervention using the AWS CLI, but most of the stuff you can do through Terraform. So the cool thing about Terraform as well is you get a plan that would show you the change, so you'd have to approve it again. So you'd review the LLM or the agent suggested changes, but you would also review the code before you apply. So I break it into parts to be able to figure this out. So here what had happened is like Stakpak is checking to see the resources and limits set on the workloads to estimate how much like the pods would be using, like how much resources the pods would be using. I don't think we set proper limits for this setup. Okay, so here for the Fargate costs, it says we have 5 pods running, no resource request and limits specified. We're using defaults. The default Fargate allocation is a quarter of a CPU core and half a gigabyte of memory per pod, running 24/7 since deployment. So Fargate pricing on EU North 1, the region we have, because it looked up the documentation in the region, it costs this much per CPU per second and this much per memory per second. So for 730 hours per month, contains this many seconds. Like I can't do the math, but like, yeah. So currently the monthly Fargate costs would cost you 36 or like $37 for the 5 pods. And the memory cost would cost you $8. So in total, about like $45 per month for the workloads. Plus the EKS control plane, $73, which makes it $118 per month. For the EC2 no group alternative, you would, for example, like you'd have to specify node size because this is not serverless. So if you have two T3 small machines, which are 2 vCPU and 2 gigabyte RAMs that can handle 5 small pods easily, that would be $15 per node. And you have $73 for the control plane, which is a total of $88 per month. So the potential saving is actually 25%. So we will save $30 if we deploy on EC2 compared to Fargate. That's why I said like EC2 is cheaper than Fargate. Even if you have like higher, like bigger nodes, like a T3 medium, you'd still be saving 12%. But like the trade-off here is Fargate is actually easier to maintain. So you don't have to have a node group. It's completely serverless. But for EC2 node groups, you have to have a node group, like a set of reserved instances. So here, if you scale down with the Fargate instances, you wouldn't pay for the extra compute. But here, if you scale down, you still have the nodes deployed to manage that. But then you can have some node auto scaling. So you can change the number of nodes as well. But like this is an interesting option. So let's actually implement this. So here, okay, update my Terraform code to use C2 node group T3 small nodes with 0 downtime. So what I'm going to do here is going to implement the suggestion to migrate to a T3 small node group instead of using Fargate. And we don't want any downtime while doing that. Kubernetes makes this easier because like it would roll out the new node group before like scaling down the Fargate node group. Now Stakpak is reading like the Terraform code. This is going to save us 25% of the costs, switching the kind of compute we're using. So this is very interesting. Like that's the cool thing about using agents with this stuff is you don't just do the analysis, but you can actually implement the like cost reduction strategies directly. But again, like as we talked about like the last Ship It session, it's usually a good idea to break things down. Like do the analysis, get the report, check it with a human first, decide to take the action, and then ask the agent to implement it for you. So here it's making some changes to our Terraform code. So it's replacing a variable. So it's adding some stuff. So variable for no groups, the instance, like the instance type, and input and stuff like that. So it's adding more stuff to it's changing the EKS cluster module we created before to switch from using Fargate to a node group. So here's replacing the Fargate profile with a new role, like all the boilerplate needed to add a node group if the node group is specified. So this is an optional parameter in the module, and attaching all the IAM policies we need for this node group to work and the node group itself, which is being created if it's if we specify this in the variable input with the IAM policies. So this is all the boilerplate and keeping the Fargate profiles for backward compatibility, like here as it mentions, because we want to do this like in a we don't want to shut down the cluster, like recreate the cluster. We just want to deploy the new node group and then scale down the old node group. Please ask any questions if you have some while we're waiting. So now it's updating the environment configurations. Instead of having Fargate profiles and that's it, it's going to add, like, keep the Fargate profiles, but also add node groups for EC2 for cost optimization. So I know the $30 sounds ridiculous, but the same thing applies. Like if you had 20 or 30 nodes, like, or 20 or 30 times the compute, you'd still save 25%. Or actually would save more because here, a big portion of the cost we're paying is the actual control plane for EKS. But if you have a huge number of nodes or like a real, like very large cluster, you would have a lot of compute that would be reduced. So here it broke things down. So yeah, phase one is adding the ECS node group alongside Fargate, which means applying Terraform code. And then phase two is migrating workloads gradually. So what Stakpak suggests here is cordoning the old nodes, like preventing new stuff from being scheduled on the old nodes, and then basically like forcing forcing Kubernetes to reschedule like the old stuff to the new nodes or draining them. And then removing the Fargate profiles and reapplying Terraform code. So proceed with the plan.
George, we have a question.
Yeah, sure.
Ravi is asking if we can update /read from an existing Git repo or create a pull resource and put cost summary in the PE.
So let me read the question again. So please loop me down if it's stupid. We use this to update read from an existing Git repo, create a pull request. Yes, definitely you can do this. But as you can see here, like in this specific example, like you need to actively, so for example, like here, we're making the changes on multiple phases. The first phase is adding the node group and then applying the code. And that's what we're doing now. It's adding the node group and applying the code. And then you need to drain the workloads to move from the old Fargate setup to the new node groups. And then you need to change the code again and apply to remove Fargate. So if you create a single PR, this wouldn't do it. You have to create a PR, merge it and apply, and then create another PR, merge it and apply. But you can definitely do that. So you would definitely be able to generate a PR and modify your code. But to finish the migration completely, you would need to apply this, create another PR, and then apply it. So it's a multi-step process. So it's not straightforward to just create a PR to handle this. Like you need to do it on multiple steps. And most non-trivial Terraform changes involve that. So if you're migrating Terraform code, refactoring Terraform code, you need to do like change the code, apply, or like do some state plumbing with Terraform CLI tool, and then apply again. It's crazy, but yeah. Yeah, so we're waiting for Terraform to create the new node group or the cost optimized node group. Yeah, of course we could name it everything, but like, yeah, it just decided to name it something too verbose. But yeah, please tell me, Ravi, if I got you right, like if you got what I said. So right, rule according to steps. Yeah, so I can show you the rulebook we're using. So the rulebook we're using now just says, okay, when you're doing cost analysis, focus first on using like cloud native. I can walk you through the rulebook as well. Like it says, let's do this together because this is going to take a huge amount of time. So let me share another screen. Okay, so here we should go for Stakpak, and we can go through together while we're waiting for Terraform to apply. So the rulebook is super high level. It focuses on like how to do the cost analysis in a systematic way. So here you see infrastructure cost estimation. It's an official rulebook, like everyone gets it. And here, like we do a couple of things. So first thing, we tell it to focus on exclude credits, because credits get in the way. Like you don't get accurate cost estimates if you include credits. So it tells you what you're paying, but not necessarily how much infrastructure you're consuming. So this is usually counterproductive. And then we break it down to things. Like first thing is to use native cost tools first. So use, for example, like Cost Explorer on AWS. And then after that, you do comprehensive discovery, because like what you see Stakpak did is we first use Cost Explorer to estimate the costs, see the trend over the past 3 months, but it also then tried enumerating all the resources we have in the cloud account to get the current status, because the changes you made in the past couple of weeks, they don't show on Cost Explorer on historic data the past couple of months. And then checks the official documentation for the current pricing information for the suitable region, and then create calculation scripts to, if the numbers are complicated, it will create a Python script to crunch the numbers to figure out the actual costs. So this is the rulebook. So we go through the first phase, tell it to focus on calculating like the primary analysis for the past 3 months. And if the user asks for like a trend, then you use the last 6 months of data to be able to do that. And we have to specify the actual time range, because we found LLMs, they screw up the timeline if you don't start from a specific time. So here we ask it to, okay, use at least the past 3 months starting today's date, or use 6 months if you want to calculate the trend. And then we ask it to for different cloud providers it's different, but we here give it a hint on how to exclude credits. It can do this on its own, but we found if we add an example here, it usually does that in a fewer steps. So instead of having 3 or 4 steps to figure out like how to eliminate or remove the credits from the calculation, this makes it easier, like gives it a shortcut. Then we ask it to do comprehensive resource discovery and in everything, like compute, storage, networking, platform security, everything. And then do some price research and official documentation, and we give it some hints on how to calculate costs. So the scripts here are all generated by Stakpak. So basically how I wrote this rulebook is I use Stakpak in the terminal to do cost estimates for different setups. And then I took the learnings from these sessions into asked Stakpak to write them in a markdown file, and then I combined them and created a rulebook. So this rulebook is basically derived from running Stakpak a couple of times, doing cost optimization on different cloud providers, and then we distill the information and put it in a rulebook. So the rulebook doesn't add new capabilities in this case, but it's just a shortcut to make Stakpak smarter at doing cost estimates in a methodical way. Yeah. Otherwise, every single time you would be using the agent, it would do the cost analysis in a different way. So we're trying to standardize how cost estimates are being done, and you can do take this and fork it and create your own. So here what you can see is the EC2 group was created and it's deployed. So you can see here we have some Amazon Linux 2 machines, and these machines, yeah, they're basically the new node group. So it's checking the engine X, Ingress Engine X. Yeah, we had an issue installing the Ingress Engine X. Yeah, I set up the cluster in a rush. That's why I didn't have the time to check if everything's actually working. So it found the issue. It's going to fix it anyway. Yeah. Yeah. So Ravi, you can do this without the rulebook, but as I showed you, like the rulebook makes it like take shortcuts to like accomplish what you're trying to do faster in a more methodical way. So instead of doing it differently every single time, the rulebook gives it a procedure that it can follow. And any variation or like anything unexpected, it would be able to work its way around these variations as it goes.
Ravi is asking how he could apply this in a real infrastructure as code DevOps workflow.
Yes, this video is going to be streamed and stored on YouTube. We also have some examples. Like if you join the Discord community, you can share with you a GitHub Actions workflow. We have a Stakpak agent action that you can run Stakpak within your CI/CD or within GitHub Actions in asynchronous mode, and you can do stuff like you can ask it to review the code or make suggestions regarding cost and create this as a PR or like just dump it down into a file or like as a result in standard output, and then you can look into it. But like something like that, like deciding on a cost estimate and then migrating it, if it's multi-step with IAC, like this is how we implement it with infrastructure as code. Like you have to apply, check stuff, and then apply again and keep doing that. If you're trying to do this with a GitOps flow, it wouldn't work as much. Like you would have to create multiple PRs. But definitely, like nothing is stopping me from putting this in a CI pipeline to generate recommendations or create a PR without like human intervention. At least there would be human intervention because you'd be reviewing the PR, but it would generate this stuff in the background on its own. So like if you want to imagine how this would look like, we can do Stakpak, run it in asynchronous mode, set max steps. So give it like a fixed number of steps to run, 10. And then we can give it a command like, yeah, this can be verbose mode or like it can be in like, let's do it in verbose mode so you can see what's going on. So here in verbose mode, okay, understand my Terraform code and write suggestions and yeah, and write suggestions for me to reduce the costs. Don't change anything, just write your expert review. Yeah. So what happens here is Stakpak is running in asynchronous mode. We're not touching it. We're not doing anything. And it's going to start exploring the file system. Here's listing like the directory tree, reading files. So the same exact thing here, like it can happen in your CI/CD. Okay, so this is all scrolling. So yeah, it's reading files. If I like, because I use the verbose flag, it's showing you everything it's reading. But yeah, you can short circuit that without like you can make it print something more terminal friendly without the verbose flag.
Ravi is asking if we can cover it from a DevSecOps perspective in another session.
Yeah, sure. So you mean adding more security, like using security features? Yeah, that'd be great. Like I used to be like, here. Yeah, it's already done. So I used to be a security engineer on a platform team, like a one-person security engineer on a platform team. So I love these kind of use cases. So I'd love to dig that deep into that. If you have specific things you want to see us do in the Ship It session related to security, just suggest stuff. The example I'm going to share with you is actually doing a Terraform security code review through GitHub Actions. So I think you're going to like that. Yeah, I would share it with you on Discord. But yeah, here, so the final agent response after running this. So it took, almost 55 seconds running this review. The key findings is we use an EKS cluster with Fargate and 3 availability zones. We have multiple NATs, which is a major cost driver, as we like the conclusion we reached on the in the other analysis, in the live analysis. CloudWatch logging enabled for 14 days. KMS encryption enabled, Nginx with Ingress and an NLB. We have multiple Fargate profiles configured and a public endpoint, which makes the cluster accessible. So here, it made some conclusions based on the code review. So this is just the code review. It didn't check the AWS account. So there's a NAT gateway, 3 NAT gateways, which is a lot of like a huge cost. And currently we can change that. So instead of setting single NAT gateway to false, we should change it to true, which would reduce the cost, because this creates 3 NAT gateways now, which is expensive. It made other recommendations other than that. So here, yeah, setting this single flag would save us $90 per month, which is great. Yeah, it also said the EKS Fargate pricing could be too expensive. So recommendation is to right size it or like use spot instance if it's not critical, for example. CloudWatch logging, we have 3, the impact is low to medium, but like the retention, we can set the retention to something lower, like 7 days instead of 14, but this depends on your compliance requirements. And yeah, it said the load balancer is costing us this much and so on. So what happened here is it made the recommendations based on reading the code without checking the actual live environment. And this is how you can use this in a CI/CD like IAC workflow in the back, like asynchronously. I hope this answers the question as well. Yeah. One thing I think agents would be really cool at from a DevSecOps perspective is being able to prioritize and like filter the static analysis tool results. So if you run a Chekhov, Trivy, or any of the IX scanning tools, you get like hundreds of results. And usually these results are not context aware. So what I would do is I would create a rule book with your context, what you're working on, what your business cares about, and then ask Stakpak to review these results for you based on the stuff you define in the rulebook. And like how you, for example, like how do you measure the impact and the risk, or like the impact and likelihood of this risk manifesting, or this specific security threat being actually applied in your environment. And then Stakpak would take these, and because it's using Claude, and Claude is super smart, is going to take these into consideration and rank the risk of the findings you get from a static analysis tool. So instead of having to look at hundreds of tool results, you just look at the most important stuff because Stakpak did the filtering on your behalf. But you can also take this like a step further and ask Stakpak to create PRs or suggest code changes to patch these these issues without you having to go through them. So there are a lot you can do on the DevSecOps side of things, with an agent. So now it's making sure that the workloads are scheduled on the EC2 machines and not the Fargate instances, because they're configured to use the Fargate profile. Yeah, so here we're changing the node selector to the cost optimized, so the scheduler would move them and prevent scheduling other nodes on the Fargate instances. Because we're trying to do this with 0 downtime. Yeah, so Ravi is saying, I've done that with Chekhov and Trivy in my ISE. Doing it with Plan AP, so seeing Stakpak doing this be great, we'll see. Yeah, exactly. So the idea is to not replace Chekhov and Trivy with an agent, but to pipe the results you get from Chekhov and Trivy into an agent with your context, so you can make decisions, like help you filter these results. So it's like a layer on top. It's not a replacement. There's also some kind of vulnerabilities that you get. So sometimes, for example, like I can even examples of a lot of false positives, but like in this case, like we have a cluster and the cluster is public. Maybe you want the cluster to be public. Like this is not a risk, like you actually accept the risk. And Chekhov and Trivy would just keep, telling you that the cluster is public and you should make it private, but you don't want to make it private. The same thing with buckets. Like if you have a bucket serving assets, you want this bucket to be public. So it's not a security risk based on the context or like what the bucket is being used at. So the static analysis tools are amazing, but they get false positives because they're not context aware. At the same time, you might have something that's perfectly normal, but it's also like undetectable by static analysis tools. So something that like a logic level kind of bug. I think there's some new tools calling these BLAST, like business logic level analysis or like business application security analysis tools. I think Corgi is a good example for this. Like we can share it with you also on Discord. So Stakpak can do the same thing for infrastructure. So it can catch logic error bugs that are not necessarily captured by static analysis tools. We can actually write some examples for you on Discord.
Ravi is saying he did this by putting an exclude rule in the repo for those cases.
Yes, exactly. Yeah. So imagine you can do this like dynamically. I think there's an error here. Like it went on a loop trying to read the file. So let's ask it to, okay. So Claude here went on a loop trying to edit the file. Yes, you can add exclude rules to exclude these stuff. But yeah, definitely, yeah. Okay, it's still not getting it right. Why is it not able to edit this right? Okay. Yeah, I got stuck editing a file. So what it's trying now is trying to create a new deployment and then scaling down the other one. Yeah, trivia ignore. Yes. I haven't used trivia ignore yet. So I'm not aware of the syntax. I'm curious actually if Stakpak can write the ignore rules depending on our feedback. Yeah, I'm still like experimenting this, but like the best way to use an agent here would be for prioritization, like taking the all the reports and then showing me the most important stuff to work on. Especially if developers are consuming these reports. Like if you're a security engineer or someone like focusing on security of the platform and you have other teammates who would have to go through the results, like at least prioritizing the most important things would like be less overwhelming. I mean, like I can't forget the developer's face when I showed them like the trivia scan of their container images, like with hundreds of vulnerabilities, and they don't know what to do because they can't prioritize them. They don't know what's actually relevant, what's important, and what's not. So I had to go as a security engineer, like create PRs to patch the containers after going through like and prioritizing the stuff myself, which is not scalable if like you have hundreds of developers in your organization. Like they have to be able to understand the reports, prioritize, and create patches themselves. Yeah, so here it says there's an issue. The EC2 deployment pods are being scheduled on Fargate instead of EC2 nodes. This is because the default namespace has a Fargate profile that's intercepting all pods. Let me fix this by creating a dedicated namespace for the EC2 workloads. Interesting. I didn't know this would be an issue, but this is very interesting. I've never migrated from Fargate nodes to EC2 node groups before on Kubernetes on EKS. So I'm learning new stuff here.
Robbie sent the syntax for Trevi ignore.
Interesting. So they came up with their own DSL for trivia ignore files. Interesting. We can actually do something. So because I didn't like I've never checked this out before, we could try to research this. So can I schedule pods on EC2 node groups when using EKS while I have Fargate profile? So let it do some research while we're working. Yeah, now they're working, but
Robbie is saying you can do it in YAML as well.
Yeah, I think the ML idea is smart. So at some point, I did a lot of I did a comparative analysis of different tools that scan for Kubernetes misconfigurations, and actually found Kyverno had the most complete tool set because they use YAML. So you would think like OPA or Rego, like admission webhook, is more popular, but apparently Kyverno is more popular because like developers or DevOps engineers, they hate writing Rego policies. So yeah, it's smart for them to use YAML. It's the easiest thing. Okay, so here it says, looking at the setup, yes, you absolutely can schedule pods in EC2 groups with the Fargate profile on the default names. Here's how it works. No groups, but no currently defined TFRs. Default namespace. Other namespace. So it's exactly like we reached the same conclusion we reached here. So what happened here is it actually worked and they scheduled stuff on the new nodes. And yeah, EC2 node group created successfully. Nginx controller fixed and deployed, created a new EC2 specific deployment nodes, and the workloads migrated to EC2 compute nodes. The pods are running on the cost optimized EC2 instances instead of Fargate. 3 pods are running on EC2. Original Fargate workloads still running in the full namespace, ready calculating extra cost savings. Okay. So now the next steps, create a clean up resources, migrate remaining Fargate workloads, remove Fargate profiles. Okay, so migrate remaining workloads and remove the Fargate profiles. So the agent is keeping nudging me. So here it keeps asking me, do you want to help you clean up those EBS volumes first? Because this is where the biggest savings are. So Stakpak keeps telling me that I'm focusing on like migrating the node groups while the most savings we can get from deleting the extra EBS volumes. It's probably right, but I'm now like a dog chasing a bone. Like I want to figure this out first. I want to know if Stakpak is aware of like the trivia you could ignore, trivia ignore. So yeah, it's migrating the Nginx test pods to like deploying them again on the new namespace. So we are able to remove Fargate with 0 downtime. I didn't know it would be that much of a pain to migrate from Fargate to EC2 node group. Yeah, I didn't expect that. Yeah, now we deployed the new Nginx. So we have a couple of sets of Nginx. We have Nginx public, which is the controller, and we have an Nginx test, which is deployment we created. Yeah, we have 10 minutes left, and we're going to get this done. We just have to clean up the old Fargate. So now it's removing all the deployments from like the old default cluster. So if we had these exposed over an ingress, we'd have to change the ingress configuration first to point to the older, like to the new deployments before phasing out like the older deployments. Okay, now update my TF code to remove the Fargate Fargate nodes from my cluster, because we still have them. Like we're not paying for them now because we don't have any pods running on the Fargate profile, but we also want to remove it from the Terraform code because we want to prevent people from scheduling new stuff on Fargate again. So we're not paying for them, but we're doing this for cleanup. So now what's going on is it's updating the variables to deprecate the Fargate setup. Yeah, it's still doing research on Trivy. I don't think we whitelisted the official Trivy documentation yet. That's why I didn't find anything here, but like, yeah, let's keep it low. Let's wait for it. Did it get what we actually asked for? Because we want to switch the default namespace back to be scheduling on EC2 node group. So okay. So I'm instructing it to make sure the default namespace will, like, stuff scheduled on the default namespace will go to the new node group instead. So whenever someone in the future tries deploying something on this cluster, it would be scheduled on the right node group. I think this is a bit like, yeah, it's cleaning things up. Okay. I think we went around like the long way doing this. Like we could have taken a shortcut. Yeah, I found some stuff about Trivy. Yeah, I found it on some GitHub discussions. But I can't find the official documentation because we haven't whitelisted the Trivy docs yet. So the reason we whitelist some official documentation is like it's twofold. Like the first thing is for security, to prevent injecting prompts by doing web research, because this is like wild web World Wide Web research. So we wanted to be like more secure. So we only whitelist official documentation pages. And the second reason is we found out this increases actually the quality of the results you get, because you're getting all this information from official docs, not from like random forum or random articles, low quality articles. So when we evaluate this against stuff like Perplexity, for example, like Perplexity is great for web search, but when looking up technical stuff in technical documentation, we found this to be much more effective because it's checking on the official sources. That's why, but like on the other hand, yeah, you get this issue where sometimes you don't have all the documentation or every single tool whitelisted. That's why we keep adding stuff. So this is, yeah, a good point for the team. Yeah, so here, as you can see, like it's removing the Fargate profile from the cluster. And destroying everything. Yeah, we have a couple of minutes left. If you have any question about anything, I would love to answer them. Like you can ask about anything, like the agent internals, stuff we tried, stuff we're working on. Like you can ask about anything. Yeah, here. So it figured out here. So trivia file, ignore file allows you to suppress specific vulnerabilities, misconfigurations, and other findings from trivia scans. Here's everything you need to know. The file location is placed anywhere. You can also use a custom path with trivia with -- ignore file. A basic format is this, like you can add CVs to ignore these CVs. Interesting. Yeah. Misconfigurations, you'd use the ID. But you can also specify a specific date, like how you mentioned it in the comments. To add false positives. Yeah, interesting. But I think it adds the whole thing as like as a false positive. Like if you have a couple of clusters or a couple of buckets defined within the same repository, like the rule would be suppressed for everything, not just the specific bucket instance, right? So, I mean, as long as you have this vulnerability or like the code within the trivia ignore file. So you can't apply the whitelist or like the trivia ignore the specific vulnerability on specific bucket, but it would be applied on all the buckets. So if you have a couple of buckets in the same module, some of them should be private and some of them should be public. Trivia, I mean, as far as this format, like it wouldn't be able to differentiate between them. Maybe it's missing something. Yeah, this is something I'd have to look up. It's very interesting. Ignore. Yeah, we can ask it that. Yeah, it's still destroying the profiles. So yeah, we're done. We're just doing some cleanup to make our Terraform code like up to date with what we're doing to prevent people from scheduling stuff on Fargate. So this is the last part. And then we have to commit and create a PR. Otherwise, I think we're done. And we're just like playing around, trying to figure out like how Trivy uses the Trivy ignore file. So looking at the docs and GitHub discussions, Trivy ignore works at the vulnerability ID level, where you have a CV or misconfiguration ID to the file. It suppresses all instances of the vulnerability across your scanner targets. So if you have this, it suppresses all instances of log4shell. And the same thing with configurations. Instance-specific ignoring options. For more granular control, you have a few options. You can do trivia ignore and have different ignore files. So you have like ignore file for production, ignore file for development for different environments. But you can also use complex Rego policies for complex logic. So then you can write Rego to create like exceptions. Yeah, now it's complicated because last time I created Rego policies for static analysis, no one like wanted to maintain them and own them. So, so if the AI would write this on my behalf, that would be great. Because like, yeah, if you start running Rego, no one else was going to touch this thing. Yeah, so here the standard thing is global suppression. There are file-based and path-based suppressions, but it's also, yeah, just by ID. Yeah.
George Ravi
Yeah,
has a question.
Yeah, okay. So Ravi was saying I would love to hear more about the agent internals. I'm new to this, so understanding the semantics would be great. As I think as a cloud engineer, this has the potential to massively improve productivity. Okay, so what would you like to learn about the agent internals? So the Stakpak agent is made up of a couple of parts. So we can actually ask Stakpak to describe that for us. So, okay. So the agent is made up of two parts. So the first part is a set of tools or MCP tools. MCP is just the standard we implement the tools with, but they're just tools the LLM uses. And there's the LLM or the brain itself. So the brain of the LLM or like the smart part just takes in the context and the available tools and just show and decides which tool to use. So you can ask Stakpak. So list the tools available to you, rule books, and rule books and system info, for example. So this would, like, I'm asking the agent to show me everything it knows about itself, like what's available to the agent. And what it does here, it starts listing stuff. So here it have access to these tools. For code and infrastructure, it can generate code, which generates and edits DevOps configurations and AIACs. Local code search, which just searches through local Terraform, Kubernetes, Docker files. So this is like we implemented a way to index infrastructure as code. And this allows you to search through infrastructure as code quickly because this index is actually like a static analysis of all your Terraform code. And it's built and stored locally in your file system in a .stakpak/ like local directory. And it maps the dependencies between different code blocks. So if you have an S3 bucket that depends on a variable, this dependency is being mapped. So this helps Stakpak or like the agent navigate your code quickly. This also can create a new file. It can search and replace for strings inside existing files. It can list directories or read files with the view tool. And there's also something cool, like the create and the view tool. They can do this remotely and locally. Like these file editing tools, they can work over an SSH connection. So you can edit remote files on remote SSH machines as well. Here are some command execution tools. So there's the run command tool, which runs a command. It can be done locally or can be done remotely over an SSH connection. There's run command async, which does the same thing as run command, but in the background. So you can use this for port forwarding or long-running tasks, like doing a load test or something. There's also some task management tasks. So get task, get all tasks, get task details, and cancel async task. These are mainly for asynchronous commands, to manage asynchronous commands. There's also some research or documentation sort of tools. Search docs is agentic search over docs, the one we just used to look up how to use Trivy tools, Trivy ignore files. View web pages, you can give it like a link to, because like the search docs is limited to a specific set of URLs to be secure and return high quality, like we discussed. You also have a view web page tool. So if you have a specific article or a specific repository you want to pass to Stakpak to read, you could just like paste the link and ask it to read it. And it would use the view web page tool to just read the page. You can also search through memories because like you can ask the agent to memorize stuff. Like at the end of every session, you can ask it to memorize what happened in the session. And the search memory tool allows Stakpak to search in its own memories. There's also some stuff related to security, like generating passwords. So we found the agent in production, like trying to generate a lot of passwords, and most of these passwords are insecure. So here what we do is we gave it a tool to generate secure passwords. So you can create this on the fly while you're working. It can also read rulebooks. So this tool allows it to choose a rulebook and read it. And in the beginning of every session, you would see we list some rulebooks available to this agent. And as you can see, like it could see some rulebooks related to a specific environments. There are some development or deployment workflow rulebooks like these. So this is rulebook on how to use Terrateam to deploy Terraform code in your CI/CD. There are some stuff like symbol deployments on VMs, configuring Stakpak action in GitHub action, and some operation and maintenance like software upgrades and software cost estimates, monitoring and learning. Like here, I was experimenting with a learning technique to allow Stakpak to learn new tools or concepts, for example. So this is the context available to the agent, and what the agent does is it uses this context to do stuff like help you migrate stuff or help you reduce costs and stuff like that. So to make the agent better, you either have to build like better tools, or you just have to add more knowledge or more rule books to make it do stuff more efficiently. So yeah, Pravi is also asking, so I have selective MCPs automatically, which are based on the best in the market. No, actually, like we build these MCP tools. So the tools you saw, we built them to work well for operations. So the run command tool streams back results from like the commands you're running. This is useful when building Docker files, so having like long running commands. But we also the file editing tools we built. So everything I showed you now, all the tools are open source. Oh, okay. Yeah, Noor kicked me out of stage. So what I was saying is the tools you saw is everything like we built and it's open source on our repository, but we're also adding soon the ability to allow users to add their existing tools. So if you have an MCP server that connects to GitHub, you can just plug this in. This is not possible now, but it's going to be rolled out pretty soon. But like we created these tools from scratch because they're like we had to make some design choices to make this better for ops. Yeah, so basically we created the tools as an MCP server and we just plug it by default in the agent. But like you would be able to add your own MCP tools if you want in the future. Yeah. So yeah, I think that's it. Like we reduced the costs or like the infrastructure costs by 25%, which is $30. But yeah, you get the idea. We also talked about like doing research, how the agent searches the web, and how to improve the quality of the search by reducing the number of like documentation, like or whitelisting documentation to official docs. We talked about like the agent architecture, the tools, and yeah, some future features we're going to ship. And DevSecOps. I think we might be able, like Noor is so into security, like we'd definitely love to do more DevSecOps content. Like I personally enjoy this a lot. So yeah.
Yeah,
so thanks.
especially it's DevCon and Black Hat season, you know?
Yes, we have to do a lot of security stuff. Yeah, amazing. Yeah, so thanks everyone. I hope you enjoyed it. Please, please, please just reach out on Discord if you have any questions or if you want to try this and give us feedback. So we're constantly working on improving this and your feedback matters a lot. So we just got like a wave of feedback last week that we've been working, like the team have been working so hard on, and it improved the experience a lot for like hundreds of other users. So this is going to help us a lot, like if you share your feedback on Discord. So yeah, have a nice day. Bye.